Hello again, everyone. Today I'm going to go over solving systems of equations by graphing. So what we're going to do is we're presented with multiple equations. That's what a system of equations is. And in this case, just two equations. And we're going to solve all of them for y, and then we're going to graph them, and then the intersection will tell us our solution. Some things to point out is that if you have two lines with the same slope, they'll have parallel lines, okay? So there'll be no solution, all right, because they'll never intersect. If you have two lines that end up being the exact same thing, overlapping lines, those will be infinitely many solutions because you have overlapping lines. So anywhere you put a dot on the line, it's a solution. So, and you can do that for an infinite number of points. So with that being said, let's get started and let's solve this first one for y. If I just minus 3 over to the other side, I have y equals x minus 3. And so I have a slope of 1 and a y-intercept of negative 3. And I'll deal with that in a second. This next one, I'll just minus x to the other side. And I'll get y equals negative x minus 1. So that gives me a slope of negative 1 and a y-intercept of negative 1. So in the black, I'm going to graph the x minus 3 line. And so that means I'm going to start at negative 3. That's why I pointed out the y-intercept. And then I had a slope of 1 over 1. So just going up 1 over 1, I get this nice diagonal line. All right. And then the next one I'm going to do in red, and I had that negative 1 y-intercept and then a negative 1 over 1 slope. So I'm going to start at negative 1, and then I'll go down 1 over 1, down 1 over 1, down 1 over 1, and so on. You don't have to fill up the entire graph with points. I'm just doing it to get a nice straight line. You saw that we intersected pretty much right away. So this point of intersection was right here. Look how good I traced that line. And that was at, looks like it's at 1 comma, and then it goes down 2 spots. So that's my solution. I just say it's at 1, negative 2. Sorry for the noise in the background. I got people going to classes and such. Alright, let's move on to the next one. I can divide everything here by negative 2. So that gives me y equals, and remember that's like a 1x, so this is going to be negative 1 over 2x minus 4. Alright, and so that gives me an m, or a slope, of negative 1 over 2 and a starting point, or a y-intercept, of negative 4. Okay, and this other one, I'll just rewrite it right here. 4y plus 2x equals 4. Alright, so I need to solve this for y, so I might as well minus 2x to the other side. And I got 4y equals negative 2x plus 4. Remember to write it in order of mx plus b. And then I just need to divide by 4, divide by 4, divide by 4. And I get y equals, that'll reduce to negative 1 over 2x. And then 4 over 4 makes 1. So it looks like I have a slope of negative 1/2. and a y-intercept of 1. So looking at this, I had a slope of -1/2 and another slope of -1/2. So without even graphing, I'm just going to say no solution because it's parallel lines. Now I'm going to go back and graph it because that's important too. Alright, so in blue, I'm going to start at -4 and go down 1/2. 1, 2, 3, 4. Down 1/2. Down 1/2. Up 1, right 2. Up 1, right 2. That's good enough. Alright. Draw your line. Okay, in the other line, I'm going to start at +1 and go down 1/2. I'll do that in red. +1, go down 1, right 2, down 1, right 2. And you see, they're never going to intersect. Up 1, left 2, up 1, left 2. Of course, you could always have a graph that intersects off the little graph that we have, but I'm not going to give you a problem that connects off of the graph. I'm not going to do that to you. You can see they had the same slope, so they have the same pattern. They'll never intersect their parallel lines. All right? Let's do this last one here. Okay, if I just add 1 to the other side, that cancels there, and I have that right there. So I have y equals -2x plus 1. So I have a slope of -2/1, and I have a y-intercept of 1. And then this one, let's see here, I can add 2 to the other side, and I'm out of room. So 2y equals -4x plus 2. So that means I should divide everything by 2. And I'm going to end up with y equals -4/2 is -2. And 2/2 is 1, so -2x plus 1. So I have a slope of -2/1 and a y-intercept of 1. And if you notice something, I have this equation and this equation. They're the exact same thing. So I know I'm having 2 of the same equations, so I'm just going to say finitely many solutions. All right. So when we graph this, we only have one line to graph. Yay, less graphing. So start at +1, and it was a -2/1, correct? Yep. So I'm going to go down 2 spots over 1, down 2 over 1. I can go up to left 1. And yeah, that should be good enough to draw our line. And yeah, just always make sure you give me several points to graph. And connect your dots better than I did. But this will wrap up the notes. We have a good example of a solution where they intersect, they clearly intersect. Another example where they don't intersect at all, so it's no solution, parallel lines. And then you have these overlapping lines, which gives you infinitely many solutions. Those are the 3 types of solutions you can have when solving a system of equations, all right? So until next time, thanks for watching. Bye.